Hello and welcome to this video on electrical current and charge for GCSE Physics and Combined Physics, and don't forget to like and subscribe. Electricity flows around a complete circuit that has a power supply, but what is actually flowing around the circuit? This is something that we call charge. Charge comes in two varieties, positive and negative. Both positive and negative charge can flow, but usually, in a circuit, we're only considering the flow of negative charge. In a circuit, these negative charges are called electrons. They're the same particles that you find orbiting the nucleus of an atom. The more electrons that pass a point in a circuit, the greater amount of charge has passed that point. The total amount of charge could be found by adding the charge on all of the electrons. Electrons have a tiny amount of charge. It's minus 1.6 times 10 to the minus 19 coulombs, or 0. A whole lot of zeros, 16 coulombs. From this, you can see why standard form is useful. The charge on one electron is too small to be particularly useful when thinking about circuits, so a large number of electrons grouped together is used instead. Approximately 6 million electrons together make a total charge of 1 coulomb. So this bucket represents 1 coulomb's worth of electrons. We need a method of counting the number of electrons that pass a point every second to be able to assess the amount of charge flow. The amount of charge that passes a point every second can be measured using an ammeter. As the charge has to pass through the ammeter to be measured, the ammeter has to be in series with the circuit. The faster the charge moves around the circuit, the more charge moves through the ammeter every second. This gives a bigger reading. This measurement is called current. It is the amount of charge that passes a point every second, and its unit is the amp, capital A. Charge, current, and time are related with this equation. Charge equals current times the time, or Q equals I times T. The units, charge Q is in coulombs, capital C, current I is in amps, capital A, and time T is in seconds, S. In circuits, we consider the current to be from positive to negative. This is conventional current and is what you should be using in your exams. But it's not actually how the electrons move. They flow from negative to positive, and this is what's been shown in these circuits. If 8 coulombs of charge passes a point in 2 seconds, what is the current? Well, we start with the equation. Q equals I times T, or charge equals current times time. We substitute in the values from the question, so 8 equals I times 2. Rearrange to make I the subject by dividing through by 2, and that gives us 8 divided by 2 equals I. And then calculate the answer. 8 divided by 2 equals I, which equals 4 amps. A series circuit with one bulb has a current of 30 milliamps. How much charge will have moved through the bulb in 2 minutes? And again, we start with the equation, Q equals I times T, or charge equals current times time. Substitute in the values from the question, but first we need to convert them into standard units. 30 milliamps is 0.03 amps, and to convert from milliamps to amps, we divide it by 1,000. 2 minutes is 120 seconds, and to convert from minutes to seconds, you multiply by 60. So now we've got our conversions, we can substitute into our equation, so we get Q equals 0.03 times 120, and that gives an answer for Q of 3.6 coulombs. Charge will only flow around a circuit if there is a power supply to cause the charge to flow. The power supply provides a potential difference to the circuit. The greater the potential difference, the faster the charge moves around the circuit, which means the greater the potential difference, the greater the current. Potential difference is measured using a voltmeter. Voltmeters are wired in parallel with the component that you are interested in. If the potential difference is doubled, then the current will also double. This relationship is called directly proportional. Potential difference and current are directly proportional as long as the temperature remains constant. This relationship is known as Ohm's law, and we cover this in another video on electricity. And that's it for this video. Thank you so much for listening.